Hey there! Now it's time for 3-point perspective, which comes into play when we rotate objects on the vertical axis, or we need it in some cases when we're looking down or up to something like a skyscraper or a canyon or something like that. So again, we're starting with a frame in which we're going to draw in. And I explained often enough already in my previous videos that this frame can be of any shape you want, and as long as it touches our cone of view, which is in this example right from the middle from this frame and touching all 4 corners. And it doesn't have to touch the cone of view with all 4 corners, just 1 corner will be enough. Now there's a significant difference from before, and that is that this horizontal line is this time not our horizon line. The height of our horizon line in respect to our eye level is correlated to the third vanishing point, and they are the same way as the 2 vanishing points on the horizon line. Now this may sound a little bit strange to you, but I can show you exactly how it is. So we are going to measure the angles again, the 30-degree angles, but this time from these both intersections. So 1, 2, 3, 4, 5, 6, and the same over here. 1, 2, 3, 4, 5, 6. Now this point is our so-called viewpoint, and now we are going to draw a triangle that is touching this line and will be at the 90-degree angle right here, like we did with 2-point perspective with the 2 vanishing points on the horizon line, you remember? And now we're going to decide at which angle it is going to be tilted, like which angle are we going to look up or down, or the object is rotated. And so I'm going to measure the angle here, let's say 35 degrees right here. And then this angle here is just 90 minus 35 degrees, which is 55 degrees if I'm correct. So 1, 2, 3, 4, 5. And right here we have our third vanishing point. And at this point here is our horizon line going to be. So let me draw that. And now it's going to be a little bit different for the vanishing points on the horizon line. What we need to do is to draw a circle from this point here, which is also called the orthogonal vanishing point, in short just OVP. And we're touching our viewpoint here, like so. And now from this point up here we are going to draw a triangle at a 90-degree angle like we did with 2-point perspective, and find our 2 vanishing points like that. So let's again rotate at 35 degrees, because why not? So 1, 2, 3, 4, 5, 6, 7. There we go. And the other one too. 1, 2, 3, 4, 5, 6, 7. Alright. And so we have here our left vanishing point, our right vanishing point, and our vertical vanishing point. And let's also label this one here. It's our orthogonal vanishing point, OVP. Alright. So what we can see is that the distance between those 2 vanishing points depends on our vertical tilt, that is, where the third vanishing point is. For example, if this angle would be much steeper, then those 2 vanishing points would go very far away from each other. And this is actually not the case in 3D space. Like here for example, I try to tilt only up and down. And what you can see is, of course, this left vanishing point will also move up and down, but it does not move to the left or to the right. Not at all. It still stays on this kind of line here. And so those 2 vanishing points will not go apart from each other. Now in our drawing they do, but the distances between the vanishing points are still in a correct ratio. And there's a special reason why we need this specific geometry. And this special reason is that if we draw lines from the vanishing points through the middle of the cone of view until we get to the opposite side, then this would be the altitude line. The altitude line is in right angle right here, and it's called altitude because if we kind of tilt it like this, for example, yeah, then this point here is at this height from this line down here. Now let's do the same over here too, and we already have it over here. And this is going to be very useful for us when we want to calculate the positions of the measure points, and this time there are going to be 6 measure points for each line here. But first of all, let's calculate the positions of the vanishing points and the height of the horizon line. So in order to save some time and not draw all of these lines, you can just calculate the distances, and this is this one right here. So we have here the radius of our cone of view, we have the angle between OVP and the right vanishing point, and the angle between OVP and the center of the cone of view. So let me quickly measure that. It is about 710. And again, we need this angle here and this angle here between the orange and the green line. So 710, then if you can remember, it was 35 degrees for both. And then we just click on solve and scroll down until we get to the approximate results. So these are the values that we entered before, and this is the distance between the center of the cone of view and the vertical vanishing point. This is the distance between the center of cone of view and the horizon line. This is the distance between OVP and the left vanishing point, and this is between OVP and the right vanishing point. And now let's measure and check if everything is correct. So we have here about 1760, close enough. We have here about 870, yeah, that's also close enough. And now we have here 2125 or something. That's very close. And here we have 1046 or something. Yeah, that's also close enough. So you see, with these calculations you can quickly determine the positions of the horizon line and the vanishing points. So all you would need to do is, you have your frame on which you draw on, you just measure the distance between the middle and the corner that is the furthest away from this middle of the cone of view. In this case, all of them are equally far away, of course. Then you decide which angle you want to tilt in the vertical axis, on the horizontal axis, like these angles here. You just quickly enter it in the calculator that I provided to you, and of course the link is going to be down below in the description. Then you get the values, you just measure it here and here, then you draw the horizon line and measure the positions of the other 2 vanishing points here and here, and there you go. And then you just draw this triangle here, and then also draw these altitude lines. Now the thing is, this is not the only horizon line, but also these 2. And to explain you that, we have our cube here again. And now we can rotate in 3 different ways, and we only talked about 2 different ways yet. So we can rotate horizontally like this, vertically like this, or like this. And well, this rotation changes the positions of our 2 vanishing points on the horizon line, the horizontal line, yeah? This rotation here changes the position of our horizon line and our 3rd vanishing point, the vertical vanishing point. And now this rotation here, what does that do? That just tilts all the horizon lines that are connecting the 3 vanishing points. So the only thing that would happen is that everything gets rotated if we rotate on this axis. As simple as that. Now let's finally talk about how to find your measurement points, because we still don't know how to draw things accurately. And for this we need to find where the middle points of these horizon lines are. And for this I'm just going to quickly measure it and then calculate it. You can also just draw it by drawing some curves like that here and there, but I'm not going to do that. Okay, I did a jump cut and found already all 3 middle points, and what we're going to do is we draw these circles here around there. And what we need to find is the intersections between the altitude lines that is on the same line as the middle point we drew the circle from, and the circle itself. So in this example right here. And now let's quickly do the others. And now we are drawing a circle from the vanishing points that are touching one of the 2 points that we measured before on the opposite side. And because we chose the same angles before, those 2 points are the same distance from the vanishing point. But if you would choose different angles, then of course you would have to draw 2 circles for each of these points here. So in retrospect, to choose the same angles wasn't the smartest idea of me, but well. And I quickly do it for the other 2 sides too. One over here and one over here. Alright, this is close enough. And so the intersections with these circles and the triangle that we have are now our measurement points. So it's actually not that hard to understand how to find these points. It's just a lot of lines that you have to draw, and it gets very confusing. I really highly recommend to you that you choose different colors too. Okay, this way it's much less confusing. I hit a lot of the lines and also labeled the measurement points too. Now we're going to calculate the positions of these measurement points. To be more precise, the distance between the altitude lines here and the measurement points on the same line. Now this time we have to do a little bit extra work because the calculator that I found is not very efficient, and because the calculations take too long, as it is doing a lot of extra stuff that we actually don't need, it just stops the calculations, and therefore we have to do extra steps in between. So the first link that we have here is we just enter the values that we had before and then click on solve. And it takes a little while. And now we scroll all the way down. These are the values that we entered before, and now these are the values that we got. And we need to write down all of these and use them in the next set. This is the second link, and we now have to insert all the values that we noted down before. Alright, and click on solve. And we scroll down, and then we can see these until A here. These were the values that we had before, and from H2 these are the new values that we also have to note down. I'm sorry for that, but it can't be avoided. And now here's the third link. We have to insert the values from the first link and from the second link. Alright, and click on solve. And now we scroll down, and all the way at the bottom we have N1 to 6, and these are the distances for the measurement points. I have the same thing over here in Mathematica, where I just need to enter the values from before and let it calculate. It's much quicker, and I can do everything at once, and then you can see the results here, which are pretty much the same as before. If you know an online calculator with which you can do everything at once, like I showed you with Mathematica, then I would be really thankful to you if you would give me the link. But please also test it beforehand. It has to be able to handle a lot of variables. There should not be any character limit and also no time limit. Anyway, now let's measure it. So we have here the first distance, M1, which is 780. Yes, close enough. Then the second distance right here, 475 or something, yeah. Then the third one, like about 800, close enough. fourth one 580, also close enough, let's say. And here 527 or something. Yes, also close enough. And the sixth one 625. It's close enough. And so instead of drawing all of these lines, you can just calculate it. And it is very helpful because this way of drawing, depending on the angles, it can be very big, like you need a lot of space. And sometimes you cannot really draw all the lines because they are way too freaking long. And you kind of have to approximate the position of the vanishing point, and you cannot draw all the lines to this vanishing point, but only in the approximate direction of it. And there, for example, here, let's say the left vanishing point would be way off, way at the left, and this vanishing point here would be a little bit closer. And so we cannot draw the complete triangle, but the lines would be cut off like this. But what we can do is, with these cut off lines, is we can still have the intersections with the altitude lines, which we can draw by simply drawing them from the vanishing point through the middle and then touching the lines there. And we can still also do it with this altitude line too. And then we just measure the distances from this altitude line, and therefore we can easily measure it instead of having to draw everything. And in this case, for example, with the left vanishing point being far away, you wouldn't be really able to do that, or it would be just ridiculous. So let's finally start drawing. So first of all, we can have our measurement scale right under our frame like we did in 1-point and 2-point perspective. And then we decide at which point we want to start drawing. Let's say at about right here. Now for the bottom square, it is still exactly the same as before. We just draw these lines, these measurement lines, from the measurement point through the point where we want to draw it to the measurement scale. And now let's say I want to have 6 units. 1, 2, 3, 4, 5, 6, like about here, and then draw all the way back again. And we draw a horizontal line right here. And now this is 1, 2, 3, 4, and 0.8 or something like that. And this is the translated scales. Now the 6 is now 4.8 right here at this position. And we want to draw a perfect cube again. And so we take this 4.8 also right here. And this time I'm not going to draw it also here, but we will have to do something else later. But as for the bottom square, you can still do exactly the same as we did in 2-point perspective. And now let's draw the lines to the vanishing points until they touch these measurement lines, and then draw the rest of it like so. And this is our bottom square. Now for the vertical line, it's a little bit different now. What we need to do is we need to draw a line from the point where we started and have it parallel to the opposite line of the triangle. And it depends on which side you are from this line. Now we are on the left side, and therefore we need the left side of this triangle. If you would be on the right side, then we would need this line here and have a measurement scale that is parallel to this line. Now we just measure what we measured before at 4.8, and then we connect the end of it with the measurement point, and we draw it a little bit longer here. And which one of these measurement points you're using depends on whether you're drawing upwards or downwards. So in this case it's upwards, and therefore we need the upper measurement point, and we need the left one because we're on the left side, and if we would be on the right side, then we would need the right ones. And now we draw the line here that goes toward the vertical vanishing point, and there we go. And then we just draw the rest of the lines, and then we have our perfect cube in 3-point perspective. And again, you can use these measurement bars to draw whatever proportions you want to. Like for example, I want to kind of cut off this cube at the top and the bottom a little bit. And therefore, we just measure here about 100 pixels right here. And the same down here. About 100, there we go. And connect it with the measurement point again until we touch the line, the blue line here. Same over here. And draw the rest. Like so. And there we go, we have the shape that we wanted. So you see, it just takes a few extra minutes and then you can do drawings in a perfectly measured way. So my series about perspective still hasn't been finished. Next of all, I want to show you some tips and tricks and nice little techniques about how to draw different shapes. And then I also want to show you how to draw cast shadows. So yeah, this so far has been the most exhausting research phase that I ever did. I mean, look at my research sheet and then you can see how much work flew into it, and I actually did even more and tried some extra measurements and stuff like that, and I kinda wasted a lot of time with it, but it helped me a little bit. Now it's time to answer a question again. This one's whether you're allowed to upload one of your drawings when you have drawn it with the help of one of my tutorials. And the answer is yes, why not? I would still appreciate it a lot if you would credit me and also add a link to the video that you have used. And if you want to show me what you have drawn, then I would be actually very interested. And if it's on DeviantArt, then I would like to add it to my collection. I already have some in there and I love every single piece of it. So the last 3 questions have been asked by the same person, and this is no problem to me, of course, and I told you, you can ask as many questions as you want. However, it would be nice if I would get questions of several people. And question for you, how do your preparations look like before you start drawing? Do you have some sort of ritual, or do you also prepare some extra special techniques? Let me know down below in the comment section. And if you have a question for me, then please ask me in a separate comment. And also let me know if you have any sort of constructive feedback or requests for me. And if you want to help me keeping the show running, then you can check out my Patreon page. Your support would be very, very highly appreciated. Alright then, have fun drawing.